Hello Advanced Algebra students, welcome back to another video on linear programming. Today we are going to look at problem number 4, which is on page 18 of your chapter 5 packet. It is a landscaping problem. So a landscape contractor uses a combination of two brands of fertilizer, each containing different amounts of phosphates and nitrates. So he's using these two different brands on the same lawn or something. Brand A contains 4 pounds of phosphate and 2 pounds of nitrate. Similarly, brand B has 6 pounds and 5 pounds respectively. So 6 pounds of phosphate, 5 pounds of nitrate. A certain lawn requires a mixture of at least 24 pounds of phosphate and at least 16 pounds of nitrate. If a package of brand A is $6.99 and package of brand B costs $17.99. What is the best buy for the lowest cost? All right, now we're talking about something different here. The best buy for the lowest cost. This is a minimize problem. We're looking for the minimum value, all right, of buying brand A and brand B. So let's let A be brand A, the number of A that we're going to buy. And then B can equal the number of B that we're going to buy. Now, we've got some constraints here in the problem. And again, what we're working through is what you found on page 14 of your packet, those steps to complete linear programming, right? So we're identifying our variables and what they represent, and now we're going to try and make a table to help us write these inequalities, but we need to figure out what the constraints are. And it comes in this line. A certain lawn requires a mixture of at least, keyword, at least 24 pounds of phosphate, at least 16 pounds of nitrates. So we have some stipulations on phosphates. I'm guessing these are all nutrients to lawn. Somebody can correct me. So phosphates and nitrates, those are our restraints. So those are going to be our two columns. And then we've got our two brands. Brand A is going to give us a certain amount of each of those. Brand B is going to give us a certain amount of each of those. And then we've got these restraints, at least 24 pounds of phosphate, at least 16 pounds of nitrate. So if we go back inside of this middle part here, brand A has 4 pounds of phosphate and 2 pounds of nitrate. Brand B has 6 and 5 respectively, so 6 and then 5 respectively. So now we can slowly start to piece this all together to write our linear or our inequalities. 4A, right, if we're looking at the phosphate stipulations here, 4A plus 6B represents how much phosphates we're getting into the lawn. It needs to be at least 24. At least 24. So it can equal 24. But the lowest it could be is 24. It needs to be at least 24 or 24 or more. So the amount we use has to be greater than or equal to that 24. Let's look at the nitrates. 2A plus 5B has to be at least 16. So it could equal 16, or it has to be more. The amount we use would have to be more than, which is greater than, or equal to that 16. The amount of A we buy, again, we can't buy negative, so it's got to be greater than or equal to 0. Same thing for fertilizer bag brand B. We have to be greater than or equal to 0. Okay, so we've translated that into the system of inequalities, and now we're going to take that information and we got to try and graph it. So I'm going to screenshot that. We're going to get a little bit of extra information, but that's okay. And then we're going to try to graph that. All right, graph the system. Let's use our X and Y intercepts. Keep it simple, I guess, right? The X and Y intercepts, we'll start with blue. All right, so let's say this is brand A for the x-intercepts. The y-intercepts we'll say is brand B. So if I'm looking at my x-intercept, 4A is 24. So 4A equals 24, meaning 6, 0. If I'm looking then at my y-intercept, it's 0, comma, 6b is 24, which is 4. Let's graph that right away. Looks like we can probably count by ones. So 1, 2, 3, 4, 5, 6. So there's my x-intercept, my y-intercept, 1, 2, 3, 4, 0, comma 4. And so we connect those. Now let's test the point 0, 0. 0 plus 0, if I plug them in, 0 plus 0 is greater than 24. 0 is greater than 24. Not true. So it's going to be everything this way. Notice I'm not going to go below the x-axis again. I'm not going to go past the y-axis because I know those are part of the constraints in this problem. I have to be positive bag values, okay? It's a little bit different here because we're going the opposite direction of what we've been used to. Now let's look at the second inequality, 2a and 5b. Okay, so now we've got 2a is 16 if I'm looking for the x-intercept. 2a is 16, that means it's 8, or 8, comma 0. And the y-intercept is going to be 0 and 5 into 16. Well, I think that's like roughly 3.2, or exactly 3.2. So 8, 0, 6, 7, 8 right here. 3.2, somewhere like right in there. So if we graph those two carefully, you're going to see there's our line. And let's test 0, 0, right? We're going to test that point down here again. 0 plus 0 is greater than or equal to 16. 0 plus 0 greater than or equal to 16. That's not true either, so we would have to graph everything above the red line. Right? Everything above the red line, including way out here, all the way up here, and over. So if we kind of try and look at this, and I'm going to use, let's use gold. It's easier. Right? Above the red and above the blue starts right here and goes this way. Then it's going to go down until we get to that intersection point, and then it's going to go above the red line, because we have to be above red and blue, and then this way. So this region, is this gold region, is not going to end. It could keep going on and on and on forever. But remember, if I go back to the original problem, it's asking us for the lowest cost, the minimum. Okay, the minimum, which means I'm not too worried about what's happening way out on the edges here. I'm looking for the minimum. And in this problem, the next step is to try and identify those vertices. One vertex is here, one vertex is somewhere in there, and our third vertex is only over here. We only have 3 vertices in this problem. Let's look at this one. 0, 4 is one vertex. Second vertex is the x-intercept on the red, 8, 0. And then the third vertex is the intersection of those two lines. To find the intersection, we still are going to be using our elimination method. So let's see how we might eliminate a variable to solve and find the intersection point. It looks like we could probably multiply the bottom equation by -2 to help us eliminate the a's. -4a plus -10b -32, right? And we're solving them pretending that they're equal signs for right now. Then we're going to add the two equations together so that the a values eliminate. 6b plus -10b is -4b. 24 plus -32 is -8. If I divide both sides by -4, I get a b value that is equal to 2, which means we still have to find the A value somehow. So I'm going to plug B equals 2 into this top equation. 4A plus 6 times 2 equals 24. Hopefully you see that that's 12. So if I subtract that to the other side, 4A will also equal 24 minus 12 is 12. If I divide by 4, I get A equals 3. So remember, A is our first part. It's the X, and B is the Y, or we get the point 3, comma 2. All right, so 3, comma 2 is that third vertex. 3, comma 2. But we're trying to find the lowest cost to this problem, which would give us the lowest cost, but still provide enough phosphorus and nitrates into the lawn chemical. So we've got to go back and create this profit equation, right? Or cost, not profit in this case, but cost. How much is it costing us? Something for every bag of A and something for every bag of B. The cost of A is $6.99, right? Cost of A, $6.99. Cost of B is $17.99. So $6.99 times every A plus $17.99 for every B. And we're going to use that profit equation in with our vertices. All right, so if I use it here, 0 bags of A and 4 bags of B is going to cost $71.96. What about 8 bags of A and 0 bags of B? Or $6.99 times 8 is going to be $55.92. Then 3 bags of A would be $20.97 plus 2 bags of B is $35.98. So if we add those together, the total cost for those is going to equal $56.95. So the best deal, the lowest cost, is actually going to be getting 8 pounds or 8 bags of brand A. And it will meet both stipulations, right? Because brand A, if we go back a page, brand A has both phosphates and nitrate in it. If I get 8 bags, right, that'd be 32 pounds of phosphate, 16 pounds of nitrates, so the bare minimum on nitrates, but it meets the pounds for phosphate, and it would cost us the lowest value by $1.03. All right, so the minimize, when they want the lowest, for that minimize, we're looking in this case for the lowest value that makes it possible. If you have questions, make sure you reach out to your teachers. These are great examples. There are plenty that we can give for you and share with you to try some more. Until next time, everyone, stay safe.